Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Standard Level Paper 2 November 2022. If you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel as well to support me. And let's get started. Ammonium nitrate and H4NO3 is used as a high nitrogen fertilizer. Calculate the percentage by mass of nitrogen in ammonium nitrate. Use section 6 of the data booklet. So to find the percentage mass, that would be molar mass of N divided by ammonium nitrate times 100. That would be 2 times 14.01 divided by 80.043 times 100. Why 2? Because there are 2 N right here. So you will get 35%. State with a reason whether the ammonium ion is a Bronsted Lowry acid or base. This is the ammonium ion. So it has an extra proton. So it wants to give this up. It cannot accept another one. So it will be Bronsted Lowry acid, as it can donate proton. Deduce the lowest electron drop structure for the nitrate ion. That would be O, O, O. So you can choose where the double bond would be. It could be right here, it could be right here, as long as it has only one double bond and then 2 single bond for oxygen. Calculate the pH of an ammonium nitrate solution with concentration of H3O plus. It's 1.07 times 10 to the power negative 5. So the pH will be negative log of this concentration, which is 4.97. Cold packs contain ammonium nitrate and water separated by a membrane. The mass of the contents of the cold pack is 25.32 gram and its initial temperature is 25.2, drops to 0.8. Calculate the energy in joule. That will be QmC delta T. So the mass 25.32 times C times 25.2 minus 0.8, which is delta T. So you get 2580 joule. The change in enthalpy when ammonium nitrate dissolves in water is 25.69 kilojoule per mole. Determine the mass of ammonium nitrate in the cold pack using your answer obtained in E1 and section 6 of the data booklet. So you just need to use a unit conversion, which is we get 2880 joule for heat. So we need to convert into kilojoule because the enthalpy is in kilojoule per mole. So 25.69 kilojoule. So you can get 0.1 mole, and mass would be N times mR. That would be 0.1 times 80.06, which is 8.01 gram. The absolute uncertainty in mass of the contents of the cold pack is 0.01 gram. And in each temperature reading is 0.2 degrees Celsius. Using your answer in E2, calculate the absolute uncertainty in the mass of ammonium nitrate in the cold pack. So because it's in each temperature reading, you get 0.2 for the uncertainties. And you know temperature difference, of course, it should have 2 readings to produce temperature difference. So for the uncertainties in delta T, we will have 0.2 plus 0.2 because it will have 2 temperature readings divided by 24.4, which is delta T. Okay, from this delta T, 25.2 minus 0.8 times 100 is 2%, and percentage uncertainty in mass, the mass is 25.32 gram. So that would be 0.01 here divided by 25.32 times 100, which is 0.04%. Okay, so absolute uncertainty will be percentage uncertainty times molar mass of NH4 and O3, which is 0.024. This, you add them both, it will be 2.04 divided by 1000, you will get, divided by 100, you will get 0.024 times mass of NH4 and O3, not molar mass, which is 8.01. It will be 0.2 gram. The cold pack contains 9.50 gram of ammonium nitrate. Calculate the percentage error in the experimentally determined mass of ammonium nitrate obtained in E2. So the percentage error will be experimental value minus accepted value divided by accepted value. So that would be 9.50 minus, this is the mass, 8.01. Okay, you get 15.7%. Solid ammonium nitrate can decompose to gases, dinitrogen monoxide, and liquid water. Write the chemical equation for this composition. Solid will produce N2O, gas, and 2H2O, liquid. Calculate the volume of the nitrogen monoxide produced at STP when a 5 gram sample of ammonium nitrate decompose. So we've got mass of ammonium nitrate, which is 5. So to find the mole, we divided by its molecular mass, which is 80.06, and you get 0.0625 mole of ammonium nitrate. So to calculate the volume of dinitrogen monoxide gas, you will calculate NV, N times Vm. So the mole will be the same because the coefficients are the same, times 22.7, so that would be 1.42. Calculate the standard enthalpy change delta H of the reaction. Use section 12 of the data booklet. So the reaction is NH4NO3 produce N2O and 2H2O. If you check on the data booklet section 12, you will get delta HF negative 258.8. Just be careful, it should be liquid because it has also for gas. Okay, so to find the delta HF, it will be delta HF product minus reactant. So that would be 82 for the nitrogen monoxide plus 2 times negative 285.8 because it's H2O minus negative 366, then you will get negative 124 kilojoule. Deduce the Lewis electron dot structure and shape for dinitrogen monoxide showing nitrogen as the central atom. Okay, so you don't need to put the dot right here. So that would be linear. Chloroquine is a medication used to prevent and treat malaria. Draw a circle around the secondary amino, this one. Determine the index of hydrogen deficiency. So C will be 18, number of C. H will be 26, X will be 1, N will be 3. So IHD would be 2 times C plus 2 minus H and minus X plus N. So we've got everything right here. 2 times 18 plus 2 minus 26 minus 1 plus 3 divided by 2, and then you will get 7. Compare, giving reason, the length of carbon-nitrogen bond in the ring to the length of the carbon N1 bond. N in bond ring is shorter as there are more electron share. It's a double bond anyway, right? And N1 is a single bond only. Single bond is longer compared to the one that in the ring, okay, in the bond ring. So this is N1, only single bond. State, giving a reason, whether carbon or nitrogen is the most electronegative element. It's nitrogen, because larger number of proton or smaller atomic radius, so easier to attract electron as the radius is smaller and has more proton, so it has higher attraction, so it will have higher electronegativity. Chloroquine can be synthesized by reacting this and B, produce chloroquine. Deduce structure of B. So as you can see here, we've got 2Cl. This will be discarded and it will change or replaced by this structure. Okay, so we can just copy this down, but the problem is this. Okay, there is NH. Amino needs to be bonded to 3 carbon group or hydrogen. So amino needs to have 3 bonds. It could be carbon, it could be hydrogen, it could be a mix between carbon and hydrogen. That would determine primary, secondary, or tertiary amino. So here, bond to 3. So 2 carbon and then 1 H. So before it is bonded is a single molecule, so it needs to be bonded to 3 carbon or mix of carbon or hydrogen itself. So let's just copy this one, the whole structure. Okay, now N as a single molecule before it's combined to produce chloroquine should have 3 bonds. So it should be H2. So it will be N, this will be with C and then H. Okay, so this is primary amino. So when it is bonded, it becomes secondary because it has 2C then. This reaction can be done with a copper catalyst. State the ground state electron configuration for copper. So that would be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, and 4s1. Or you can just do with the short notation, 4s1, 3d, 3d, 10, 4s1. Okay. Annotate the Maxwell-Boltzmann distribution curve showing the activation energies for the catalyzed and uncatalyzed reaction. So this part will be with catalyst and this part will be without. So this area has a larger proportion of molecules with energy above activation energy, and a lot more reactant can successfully overcome the activation energy when the activation energy is lower because of the additional of catalysts. Explain, referring to the Maxwell-Boltzmann distribution curve, the effect of a catalyst on a chemical reaction. Obviously, it will increase rate of reaction and cause greater area under the curve past activation energy, or you can say greater proportion of molecules that have energy bigger or equal to energy activation energy than activation energy without catalysts. Okay, it has a greater proportion than activation energy without catalysts. Consider the following reactions: Cu2 plus, Fe, Fe2 plus, and Cu. State the ground state electron configuration of Fe2 plus. Number is 26, so 1s2, 2s2, 2p6, 3s2, 3p2, 4s2, 3d6. So because it's 2 plus, then there is no more 4s2. So you can also write with short notation 3d6. The mass spectrum for copper is shown. For 63 is 69, and for 65 is 31. Show how a relative atomic mass of copper of 63.62 can be obtained from this mass spectrum. So you can do 63 times 69 plus 65 times 31 divided by 100, or 0.69 directly you divide it by 100 plus 0.31 times 65. The diagram shows an unlabeled voltaic cell for the reaction. For Cu plus 2, 0 plus 2, 0. So for Cu2 plus, as you can see, reduction because reduced number, oxidation number, and for Fe is oxidation. So anode, it's oxidation, cathode is reduction. Okay, so for oxidation, that would be Fe, the electrode, and this would be Fe2 plus because lose the electron for oxidation. And for this, obviously Cu, and then this one also Cu2 plus. Write the half equation for the reaction occurring at the anode oxidation, that is Fe. So Fe solid will lose 2 electrons and produce Fe2 plus aqueous. The diagram includes a salt bridge that is filled with a saturated solution of KNO3. Outline the function of the salt bridge. It will keep each half cell neutral. How? As you can see here, the production of Fe2 plus, okay, increases in the solution, and electron flow from the anode to the cathode. So there will be so many electrons right here. So there will be a lot of electron right here, and this will be 2 positive because the production of Fe2 plus. This will become 2 negative because of the electrons movement from anode to cathode. So we have KNO3, that would be K plus and NO3 minus. So NO3 minus will go towards this way, and K plus will go towards this way because 2 negative right here is too much or too many electrons. So K plus will neutralize this area. NO3, because 2 positive, too many Fe2 plus are produced, so it will also neutralize this area. All right. So predict the movement of all ionic species through the salt bridge. So as I already explained before, NO3 minus moves to anode, K plus moves to cathode. NO3 moves to anode, NO3 moves to anode, K plus moves to cathode. An organic compound A reacts with ethanoic acid to produce B using concentrated sulfuric acid as a catalyst. Deduce the structural and empirical formula. So when alcohol reacts with ethanoic acid, it will produce ester. This OH and then this one H will be discarded and produce H2O. So O will be directly bonded with C by keeping this. Okay, so the structural formula, let us just copy it. So H, C, C, double bond C, H, so it will be C, H, H, C, H2, O, directly bond to the C, double bond O, C, H3. If we calculate, that will be C6H10 O2. So the empirical formula is the simplest one will be C3H5O. Explain with reference to Le Chatelier principle the effect of using dilute rather than concentrated sulfuric acid as a catalyst on the yield of the reaction. Water is a product. The equilibrium will shift left, thus yield will decrease. As you can see here, water is one of the product. So if you use diluted sulfuric acid, that will increase the amount of water. So if the amount of water increases, it will make equilibrium shift to the left, right? Because the amount of product now increases. So when the equilibrium shift to the left, of course, the yield will decrease because it's favored reactant. Explain with reference to the intermolecular forces why B is more volatile than A. A contains OH hydrogen bond, while B only has dipole force. Thus, the intermolecular forces are weaker in B. As you can see here, A has OH, but B as a product doesn't have OH anymore, only double bond O and double bond C, so it has only dipole forces. So of course the B as the product that has weaker intermolecular forces, it will be easy to evaporate or more volatile compared to A, the one that has hydrogen bond. Compound A can also react with bromine. Describe the change observed in A is reacted with bromine. Compound A, it has C double bond C. It will turn orange to colorless because adding bromine water that has orange color to alkene will turn the orange color to colorless. This is to differentiate whether the compound has alkene, double bond, or alkane. Lignite, a type of coal, contains about 0.4% sulfur by mass. Calculate the amount in mole of sulfur dioxide produced when 500 grams of lignite undergoes combustions. So we can find mass of sulfur 0.4 times 500, which is 2 grams, and we can find mole of sulfur, which is 2 divided by 32.07, 0.062. This will be the same amount or mole for SO2 because it has the same coefficient. Write an equation that shows how sulfur dioxide can produce acid rain. So it will be SO2 gas dissolved in water produce H2SO3 aqueous acid rain. If it's H2SO4, this will be SO3. Okay? Sodium thiosulfate reacts with hydrochloric acid as shown. The precipitate of sulfur makes the mixture cloudy, so a mark underneath the reaction mixture becomes invisible with time. Suggest two variables other than concentration that should be controlled when comparing relative rates at different temperature. You need to keep intensity of lightning in the lab, so you will not make a mistake when you see when is the mark disappear, because the solution will turn opaque. And volume of solution also needs to keep it the same, and then color of background of mark, so you will reduce kind of error when you see when the mark is disappeared. So you can choose two from these three. Discuss two different ways to reduce the environmental impact of energy production from coal. You can remove sulfur from coal. This basically pre-combustion and post-combustion, or add lime during combustion, or reduce proportion of coal that it's used, or not allow sulfur oxide to be released into the environment. So that's all for the chemistry standard level paper 2 November 2022 explanation. If you guys find this video is helpful for your exam preparation or revision, don't forget to subscribe and let other friends of yours know about my channel to support me. So bye for now.